not 1, it's not easy to go right into the two parentheses that multiply and give us this polynomial. So we're going to factor by grouping. So multiply a times c. A times c, the product is -6. That's a 3. So the product of a times c is -6, and we want to add to the coefficient on the linear term, or b, which is 5. Alright, so let's list all the factors of 6. 1 and 6, 2 and 3. Keeping in mind that we want to add to get +5, however, one of the two factors in a set has to be negative. Well, if 2 or 3 is negative, the sum's not going to be +5, so it looks like it's going to have to be 1 and 6, and if I make the 1 the negative and keep 6 positive, the sum is going to be 5. So -1 plus 6 is 5. So we're going to use these coefficients to help us, or these numbers as coefficients to help us factor by grouping. So keep the first term. Okay, we're going to break 5x into -1x and 6x, and because we only have one negative, let's put that first. So it's -1x plus 6x, because that sum will give us 5x, and then we keep the -3 and bring down the equal 0. And again, I just like for the visual to rewrite the problem here. Okay, and then what we're going to do is we're going to go back and we're going to factor by grouping. We're going to group the first two and the last two. And notice this is an addition sign, so we don't have to make an adjustment and change that sign. Okay, then what we're going to do is in each group we're going to look for a common factor. So this group has a common factor of x, leaving 2x minus 1 plus. And the goal here is when we factor out a common factor that we're left with the same parentheses, 2x minus 1. And if we don't have the same parentheses, we probably made a mistake. So factoring out of 3 leaves 2x minus 1. Alright, then we're going to factor again. Okay. And then from each of these two terms, we see the common factor is 2x minus 1. So that's going to fill one of these binomials. When you factor out 2x minus 1, you're left with x. When you factor out 2x minus 1 from here, you're left with +3. We factored it. Now it's time to solve. Set each factor equal to 0 and solve. Add 1, divide by 2, so x is 1/2. And I have checked it. It's a good solution. Check the -3, it's a good solution. Alright, so continuing to factor by grouping, let's do one more for continuity. I don't think we've done this one. No, we haven't. So, okay, we need to factor. And because a is not 1, it might be a little bit difficult to go right to the breakup of the two parentheses, so we're going to factor by grouping. Multiply and get -6. Oh, come on, pen. And we're going to add to get -1. 1 and 6, 2 and 3. Notice that we need a product of -6, so one of the two factors has to be negative to produce that, but we also have to keep in mind we want to add to -1, so it looks like it's going to be 2 and 3, and if we made the 3 negative, that's a comma, the sum is going to be -1, so that's going to be the appropriate set of factors. So come over here, we're going to keep 3x squared, we're going to keep -2, but here we're going to have to break that apart into 2x and -3x, and I'm going to put the -3x up first, just so I don't have to worry about changing the sign. And then the -2 just comes from the constant. first group, leaving looks like x minus 1. Take out a common factor of 2 here. That leaves x minus 1. Good. That's good. You want the same factor. Same binomial factor. And then in this group and in this group, we share an x minus 1. And when you factor it out, you're left with 3x plus 2. Set each factor equal to 0 and solve. Subtract 2, divide by 3, so it looks like x is negative 2/3. I did go ahead and place each of these back into the original problem one at a time and check, and they both work. So that's factoring by grouping. Alright, and just one more factor by grouping. So minus. Okay, that's equal 0. Okay, it would be difficult to go straight to the two binomials that multiply and give you this, because it'd be hard to figure out what goes in the first position here, because 1x times 8x gives you 8x squared, 2x times 4x gives you 8x squared, and then also we have choices on factors of 4, so that's too much trial and error. We're going to do factor by grouping. So what multiplies to a times c, or positive 32, but adds to negative 33? Factors of 32. Always start with 1. 1 and 32. Go to 2. Goes in 16 times. 3 is not a factor of 32, but 4 is 8 times. 5 is not a factor, nor is 6. 7, 8 is, but we are already repeating, so we're good. Alright, choose a set of factors whose sum is negative 33, but whose product is 32. So, looks like I'm going to have to make both of the factors negative, so the sum is negative, and it looks like this first set, when added, would give us negative 33. So now we know the appropriate breakdown of negative 33x. Breakdown meaning split it into two terms that add to it. So keep 8x squared. Okay, notice that both of these are negative, so we don't have a choice in putting the negative up front. So minus either 32x or minus x, doesn't matter. The order, it'll all come out at the end. But the sum, just check, does equal negative 33x, and then don't forget the plus 4. Alright, we have 4 terms so that we can do 2 groupings. Alright, again, be careful here, because what you're about to do is you're about to take this subtraction as a negative away from x. Okay, so we're going to have to make the adjustment here to a minus. Just double check. Distribute, you get back to negative x. Distribute this negative with that negative, you get back to a positive 4. So that's the kind of tricky part about factoring by grouping. Alright, common factor here, common factor here. Looks like I can pull out an 8x. I'm left with x minus 4 minus, there's not a common factor other than 1. 1 goes into everything, so put the 1 up front, you're going to need it. Alright, and then let's look at these two groups now, these two terms, and take out the common factor. Well, they share x minus 4, and what's left over is the factors of 8x minus 1. Set each factor equal to 0 and solve. Add 1, divide by 8, we get 1/8. I've checked them both, they both work, they're both good solutions. Alright, so factor by grouping is just the mathematical way that we factor when a is not 1, and it's really your box method. Alright, that was a lot of time spent on solving by factoring. Now it's time to move to the second of the 4 ways to solve a quadratic equation, and the second of the 4 ways is to do extracting square roots. Alright, so when we extract square roots, what does that mean? Well, I mean, notice that this equation right here doesn't have a linear term, doesn't have an x term, but it does have a constant term. Okay, so it's different than our very first example where we had an x squared term and an x term, but no constant. So if we don't have the linear term, the x term, okay, we can use this technique of extracting square roots by isolating the x squared term. So I'm not going to be solving for 0. I'm not going to be putting it in the general form. Just because I identify I have no linear term, okay, the way I can do this is I can divide both sides by 4. So the result is x squared equals 3. That's a nice number. Alright, I'm going to write the problem down again, because what I'm going to do is I'm going to bring in the square root, because all I have to do here is bring in a square root to undo the square, and I'm going to bring in a square root here. Alright, this is where it might get a little different. If you have an even root, or even power, sorry, if you have an even power here with an even root, this is square root. If you have an even, not odd, okay, there can be two solutions, and we're going to take that out as an absolute value of x. So had this been an x to the 4th, or an x to the 6th, or 8, or any even number, when you bring in the appropriate root, if this had been 4, I'd bring in the 4th root. Okay, this is going to come out as the absolute value of x. So the absolute value of x is equal to the square root of 3, and I can't simplify that, so I just bring it down. But I want to solve for x, so I'm going to remove the absolute value, but when I remove the absolute value, that's when we're going to include the positive and negative solutions. So one solution is positive square root of 3, one solution is negative square root of 3. Common practice has them write the solutions in order like this. I could have boxed this line, but sometimes the visual of seeing them separate makes us realize there are two different solutions. I have checked them, they both do work. So, extracting the square roots. Alright, we can still use this technique right here, extracting square roots, even though we have a binomial square. If you wanted to, you could FOIL or distribute or box this. You could subtract a 7, put it in general form, solve for 0, and then factor, and it would work. But let's take advantage of this gift that we have right here. This is a gift. Okay, we're going to use the technique of extracting square roots. Okay, this is already an x, if you will, x squared or something squared, just like we had here. So I'm going to write the problem down again. I just like the visual of what we're about to do. Okay, then I'm going to bring in the square root. Square root will undo a square on both sides of the equation. When you square root a square, you're left with the quantity x minus 3. Well, remember, this is an even root, so I would bring out all of x minus 3, putting it in absolute value. Bring down the square root of 7. Right, to continue solving, when I remove the absolute value, I'm going to make the adjustment over here and put positive, negative, square root of 7. For me to get x by itself, I'm going to have to add a 3 to both sides. Common practice has us add a 3 but not put it at the end, put it before the plus minus. So when I add a 3, I'm going to put it first, plus minus, square root of 7. One solution is 3 plus square root of 7, one solution is 3 minus square root of 7. I could box that, or I could write them out. The smaller of the two numbers would be 3 minus the square root of 7, and the larger of the two would be the 3 plus the square root of 7. I've checked them both, they both work. Okay, let's do another one. Alright, so again, you could FOIL, box, multiply, distribute this all out, add a 9, set it equal to 0, and attempt to factor it. But let's take advantage of this gift. Okay. I'm going to write the problem down again. I'm going to bring in the square root to undo the square on both sides of the equation. Okay, square rooting a square results in us bringing out the absolute value of 2x minus 1. Because it's an even power. If it was odd, I'd just bring out what I see. I wouldn't put it in absolute value. It's not odd. Okay, so I'm going to bring out the absolute value. Now I'm coming over here and I'm real solutions. So in this case, I'm just going to say, bring this down again maybe, and then as a result of analyzing what's going on here, I can't have that. I'm going to put circle with a line through it. Circle with a line through it is a symbol in math that means no solution. So that was kind of nice. We have no solution because you can't take the square root of a negative number. Alright, let's try and do one more and see what happens. Alright, if we just looked at this equation, if we're going to attempt to solve it by extracting square roots, I'd bring in the square root on both sides of the equation right here and right now. But notice that's going to result in the square root of a negative number. Well, just like the previous example, example 3, there's not going to be any solution. So it is perfectly acceptable for you to analyze this and go, you know what, circle with a line through it, no solution. Why even take the first step if you see that when you square root this, you're going to get an imaginary number? So that's kind of nice if you use this technique. Otherwise, if you were to FOIL and add 6 and put it in general form and attempt to factor, it's going to be a lot of work just to get no solution. So this might be the best technique. All right, so in these last 2 videos, we looked at solving quadratic equations by factoring and extracting square roots.